The NOVAFOODIES project is a project that's funded by the European Union, and we are looking at new functional foods for European consumers. So we're working along the entire value chain, from production to processing to final product. So we're looking at how we can improve cultivation techniques in cultivation of marine and other aquatic organisms. And then we're also looking at how we can improve processing technologies to make it more sustainable and less energy intensive. It's a circulating system, a recirculating system, so we use very little water. We don't have to change the water because it's constantly treated and recycled. So that makes us completely independent from being close to the sea, close to the coastline. And it also allows us to cultivate the organisms under any temperature conditions. And also we can grow them wherever we want.
We have scaled up our production to the large tank system, which means we went from 300 liters of water volume to about 5,000 liters. And in this large system, we are harvesting 4 kilograms of algae each week and up to 240 kilograms per year. We have 6 semi-cylindric tanks with a total volume of about 5,000 liters. And the surface area of each is about 1.8 square meters. The 3 tanks in the front are already running and filled with algae since April of this year, and we're harvesting every 2 weeks. The water is being recirculated, which means it goes through these outlets down here into the sump tank, and there it's being cleaned and disinfected and put back into the tank. There is a perforated air tube running along the bottom of each tank, from which air bubbles constantly rise. And due to the dimensions and the shape of the tank, they will create an upwelling pattern which moves the algae around and ensures that all of the algae in the tank can get sufficient sunlight, and also oxygen and carbon dioxide will be properly distributed throughout the water. In each tank we also have a surface level sensor which constantly measures the temperature and the light intensity on the water surface. And this is in addition to our daily water samples, in which we measure the pH value, the salinity, and also the temperature of our water. Here we have our lamps set up above the tanks. They provide at least 12 hours of artificial sunlight per day to simulate summer conditions. This ensures that the algae can grow even in the dark months. Here you can see our protein skimmer. In this water column, a dispergator pump creates very small air bubbles that rise up here and create a lot of foam. And this foam will catch any small particles and excess protein in our water and just foam it all up and carry the particles out here so they can be removed from the system, and the cleaned water will be pumped back into the sump. So this is our sump tank, and the water that comes out from the tanks will all be collected back in here. And in here we have 2 pumps, one that supplies water to the protein skimmer and the other that transports water back out of the tank through our UV disinfection unit and back into the tanks. Down here we have our UV disinfection unit and our cooling units. In the UV disinfection, the water will be pumped through a tube and be exposed to UV lighting, and this kills off microbes and diatoms and other harmful contaminants in the water. And afterwards it goes into the cooling units, where we maintain a water temperature below 20 degrees even in the summer. This is very important because we are cultivating cold water algae.
Yeah, my personal goal is that we are able to show that we can produce 750 kilos of seaweed biomass per year in these land-based systems. Using these recirculating systems is quite unique for seaweed cultivation, especially without combining them with other organisms. And therefore we want to be able to show that we can produce such a large biomass in actually quite a small area, and to use the biomass in the biotechnology industry.